Okay, ladies and gentlemen, let's talk about more functions as series. Now, we've already talked about 1 over 1 minus x can be approximated by the series from 0 to infinity, x to the n. Now, we also have our old buddy e to the x, because these transcendental functions, these things that are not polynomials anymore, they become much more difficult to work with. So what we want to do is we want to be able to take weird transcendental functions and we want to approximate them using polynomials that we're much more familiar with, but more importantly, when you get to calculus, are much easier to work with. So with that, we need to talk about e to the x. Well, whereas 1 over 1 minus x was simply x to the 0, x to the first, x to the second, x to the power series. Again, remember, power series. Here, e to the x is going to be somewhat more complicated. It's going to be x to the n, but it's divided by n factorial, so it brings along its own coefficients. So if I say x to the 0, 0 factorial, well, x to the 0 is 1, and 0 factorial is also 1. Now I have x to the first over 1 factorial, but 1 factorial is, again, just plain old 1. X squared over 2 factorial, plus x cubed over 3 factorial, so on and so forth. So this isn't so bad. Cosine x becomes a bit more challenging from 0 to infinity. Now we have this negative 1 to the nth, x to the 2n over 2n factorial. Now, in calculus, we can learn how to build this entire thing. But for now, just accept that this is the polynomial that would best approximate this cosine. One of the kickers is, if you will remember, the graph of cosine starts up, goes down, comes back up, goes down, comes back up. And among the things we need in here is this negative going back and forth between positive, negative, positive, negative, positive, negative, to keep the graph moving. Okay, so that's why we have a positive, a negative, a positive, a negative, a positive, a negative, yada, 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 all the way to the end. So using this, although this is ugly, this series isn't really that bad. Sine x, let's go ahead and figure out what it would be. Well, it's negative 1 to the 0 power x to the 2 times 0 plus 1 all over 2 times 0 plus 1 factorial. If that's the case, well, this raised to the 0 power is going to be 1. X to the, well, that's 0 plus 1, so we end up with 1x to the first because the plus 1 still hangs around. All over 2 times 0 is 0 plus 1, the whole thing factorial, 1 factorial. Now, for the next piece, when we plug in negative 1 to the first, x to the 2 times 1 plus 1, all over 2 to the 1 plus 1 factorial, we end up with, yes, a negative sign, but then we also come up with x to the, well, 2 plus 1 is 3, all over 3 factorial. Now, before long, you should be able to recognize the pattern as it begins to come at you. And you end up with sine here. Now, it does make sense. Since cosine is an even function, you're going to get even exponents. Since sine is an odd function, you're going to get odd exponents. Those are the 4 key series that you need to memorize. You need to know this equals the summation formula, which turns into the polynomials. And by taking various partial sums of the polynomials, we can get very good estimates of the original graph. To that end, let's go ahead and do a problem. If I want e to the 1.3, now, I could get e to the 1.3 in fairly short order by simply going to my calculator, using the calculator to say second e raised to the 1.3, and the calculator approximates it to 3.66929. However, what we can do is we can use our formula, and let's use the 4th partial sum. So if I use the 4th partial sum, I could take e to the 1.3 is going to equal the summation of from 0 to infinity x to the n over n factorial. But I'm only going to the fourth, so I'm going to say 0 to 3, and we can write it out and say that we end up with 1 plus x to the 1 over 1 factorial plus x to the 2 over 2 factorial plus x to the 3 over 3 factorial. And if this were to the seventh partial sum, eighth partial sum, 10th, we just add more terms onto it. In this case, it's to the 1.3, so I'm going to put 1.3 everywhere I see x. Now I can plug it into my calculator. And assuming I get all my buttons right, 1 plus 1.3 plus 1.3 squared divided by 2, because 2 factorial is 2, plus 1.3 raised to the third power divided by 3 factorial is 3 times 2 times 1, so it's 6. Hit enter, I come up with 3.5111. And so I come up with an estimate of this value, 3.699929, 3.5111166, and that's how I approximate. Your job is to do, number one, I want sine of pi over 5, and I want, number two, cosine of negative 3 pi over 7. Those are the approximations that we need. All right, give that a whirl.